Hello, welcome to this Trapcode mirror tutorial. First I wanted to talk a little bit about the history of the plugin, why I created it in the first place. And it has to do with something that happens with Trapcode form, so I'll show that. So this is a typical form animation with the fractal field displacing the particles. The thing is, sometimes you don't like this particle look, you would like it to be more of a surface. And so what you end up doing is increasing the number of particles, so you get the really dense particles, and perhaps decrease the opacity a little bit, and you get some really nice looking shapes this way. But the more and more particles you add, the slower it gets to render, and it can get just too slow. So that's the problem I wanted to address with mirror. So let's go ahead and apply mirror here. Create the composition size 2D layer and apply mirror, and I can crank up the geometry a little bit here. Let's do 200 by 200, and let me take down the opacity a bit of this. And as you can see, it's very similar to that form thing, except it's a lot faster. And if I wanted to make this move, I can just move the evolution here. Okay, so that is that was the initial motivation for creating mirror, but of course since then it has evolved a lot. And now let's look through some of the features. Okay, so the basic idea here is very simple. It's let me switch actually to wireframe so you can see what's going on here a bit more. And let me decrease the geometry a little bit. So it's just like this big mesh, rectangular mesh of particle, of vertices that makes a polygon mesh that I can displace using a fractal. And that is really the basic idea. And then I have some other things I can do. I can bend the whole mesh, and of course I can apply the fractal on the bent mesh. I have two different bends here, and these two can be combined. And there's even some more bend options down here. There's two more, and the difference is these two are applied after the fractal. So if I have some fractal displacement going on here, and maybe I'll increase the size a little bit of this thing. So now I'm bending up here, and if I move the fractal on the X, you can see that it really moves the whole fractal on the X-axis. But if I had used this bend instead, then I'm also bending the fractal. So now when I move the offset, you can see it's moving the whole, it's moving it along the bent shape. So that's the difference between the bends down here. These are applied after the fractal, these are applied before the fractal. Okay, now let's have a look a little bit more at the fractal itself here. You can just remove this bending. So yeah, obviously the amplitude controls how much displacement there is from the fractal. There's also frequency, which controls the detail of that displacement. So if I wanted really high detail, I set this up. Perhaps then I want to also decrease the amplitude a little bit. Or if I wanted a low detail, I take the frequency down. But I'll use something like this maybe. It's pretty cool. Evolution is just evolving the fractal, kind of randomly undulating the whole thing over the whole thing at the same time. So I could make this move in time by just adding an expression, time times 20. I could keyframe it also. I tend to prefer expressions for simple things like this, because if I extend the timeline, it will just, keep on working. But I could just set 2 keyframes, and that would be very similar. So that's looking pretty cool. So, well, what do we have more here? Well, the offset, it offsets the entire fractal in that direction, and I can offset in the Y direction. Now that this looks a bit, see, it's a bit hard to see that, but it's actually offsetting it in the Y direction. But yeah, and then we have the scroll things here, and they are very similar to the offset, except, see if we can get a good view at this. You can see when I'm using the offset, the fractal is moving inside, or it's moving unrelated to the vertices. So the vertices become, you see this kind of undulating motion, which, you know, looks pretty cool, but sometimes you would like it to be more like this, like a straight panning motion, and then you can use the scroll features. So these, I could set an expression here, and this could just keep going and going and going forever. It doesn't end. I mean, it just keeps, as you can see here, it generates new geometry here and removes the geometry over there. So it can just keep on going forever. So that's the scroll. And then we have complexity is kind of the smoothness of the whole thing, or the detail. I mean, this is obviously also detail. So these things, the complexity decides the number of noise layers that should be added together. And the frequency is the frequency of those layers. So this is more if you want a smoother shape or a more detailed shape, but keep the general shape the same. Just add detail or remove detail. Yeah, scale and multiply also controls the noise layers that are added together. Amplitude, I can show that. Switch off the bending here. So by default, it just displaces on all three axes, but I can limit that. For example, I could switch off the X and Y, and I'm left with just only the Z coordinate is displaced now. So this can be used to create this kind of height field and look. And let's see if I can just make it a little bit bigger on this axis. Perhaps take down the frequency. So this I can, of course, combine with scroll here to just make an eternal surface that keeps appearing, kind of like the camera is flying over this thing. And I could hide the end here by using fog or something. Okay, and then we have the frequency in the different directions. So I can set, set down the frequency in Y, and I can get this type of effect from that. And there's even an amplitude layer where I can actually use create a composition, and I'll just create solid. Let me do a circle in here and do some feathering. Bring that comp in here, switch it off, and then I can select that as an amplitude layer. And as you can see, where the white was in the pre-comp, that's where the fractal displacement is happening. So this is very useful for controlling where on the mesh the fractal is being applied, and it can be used to shape the whole thing. Okay, I think that's it for the fractal section. So let me just switch off this. Let's have a look at what's left up here. Well, obviously the positioning controls and rotation. I've just been using the camera here because since I don't have anything else in the comp, I'm free to use the camera. But anything that you're doing with the camera, you could do with these things here. There's the vertices. This is, of course, a very important control. The more vertices you have, the slower it gets. On this card that I have, I can set this up pretty high and still get really good rates, as you can see. But it really depends on the card. Maybe on a laptop 200 by 200 is it can start to get slow, but yeah, you have to try that out on your own machine. It depends on the GPU that's in it. This is a GTX 580, by the way. And okay, okay, let me drop those back down a little bit. 200 by 200. Then we have the step, which very simply just jumps over polygons. So and I can combine this different steps together, and so it just creates this kind of strippy look. And I've already covered the band. Reduce geometry, I kind of mentioned that. Very useful for quickly previewing stuff. You could just take it down. And also it's also quite fun to inspect different complexity levels for the thing you're creating. All right, so then the last thing in this tutorial will be the repeater, which also it's very simple. It's similar to 3D stroke. I can make repetitions of the shape, and I can, for each repetition, I can apply a rotation, for example. So it's actually more fractal. This and this back to, so you can get some nice repeated shapes. And I can also do scaling, and I can fade out the opacity. Okay, so that concludes this first tutorial on how to shape things with Mir. The next tutorial will be about how to set up the shading. Thank you for listening. Bye.